Hello, welcome to Ludic Science. This is the second video on the series on operational amplifiers. In the first video, I explained the very basic of the operational amplifier, and in this second video, I will show you a very simple application, which is a voltage level indicator circuit. This one, of course, it's made with operational amplifiers, 4 of them, and the visual output is with 4 LEDs. So let's see how the circuit is made and explain how it works. Let's remember how the operational amplifier works. It has 2 inputs, an inverting input and a non-inverting input, and 1 output. And we also have the positive voltage V plus and negative voltage V minus. Now, the voltage at the output depends on the voltages at the input. If the voltage at the non-inverting input is higher than the voltage at the inverting input, for example, we have 5 volts here and 3 volts here, the output will be V plus. On the contrary, if we have a higher voltage in the inverting input than the voltage in the non-inverting input, for example, we have 10 volts here and 0 volts here, then at the output we will obtain V minus. Next time you need a PCB for your electronics project, consider using the professional services of JLC PCB. JLC PCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. Here is the schematic. It has 4 operational amplifiers. I am using the 741, which is one of the most common op amps. At the outputs, we have 4 LEDs with its current limiting resistor, which is 330 ohms in my case. And here we have a voltage divider, 4 identical resistors, 1.2 kilo ohms each, and it is connected to 9 volts. So the 9 volts will be divided in 4 equal parts. Therefore, at this point, we will have the 9 volts of the input, 6.75 volts here, 4.5 and 2.25 volts. And of course, 0 volts at this point. And each of these voltage levels is connected to the inverting input of each operational amplifier. The non-inverting inputs are connected all together and they go to the input voltage that we want to monitor. For the input voltages of the operational amplifiers, all the negative voltages are connected to ground, and all the positive voltages, it is not drawn here for clarity, but all the positives are connected also to 9 volts. So how the circuit works? Okay, let's suppose that we have 0 volts at the voltage input. Therefore, all the non-inverting inputs will be at 0 volts, and that voltage is less than the voltages at the inverting inputs, because the lower voltage is 2.25 volts. Therefore, all the operational amplifiers send the ground voltage to the output, and none of the LEDs will be on. However, if we increase the voltage, for example, to 2.5 volts, we will have here 2.5 versus 2.25. Therefore, the voltage at the non-inverting input will be higher than the voltage at the inverting input, and the operational amplifier will send to the output the positive voltage, which is 9 volts, and this LED will go on. However, in the second op amp, we will have 2.5 versus 4.5, and the LED will not be on because the ground voltage will be sent to the LED. Now, if we increase the voltage even more, for example at 5 volts, this op-amp will send positive voltage to the LED because we will have 5 versus 2.25, and here we will have 5, which will be higher than 4.5, and this LED will also be on. This will be off because 5 is less than 6.75, and this also will be off. And so on, as we increase the voltage past the voltages of the voltage divider, the LEDs will start to turn on in sequence. Here we have the circuit on breadboard. We have the 4 741 operational amplifiers, the 4 LEDs, with each one with its limiting resistor, is 330 ohms each. Here we have the voltage divider formed by 4 identical resistors, 1.2 kilo ohms, and all the connections as per the diagram. Okay, let's see how it works. The 9-volt battery is for the voltage divider, and with the variable power supply I will increase the voltage to see how the LEDs start to turn on. So let's see, let me increase the voltage. The first LED goes on, increase more. Now the second is on. Now we have 3 LEDs on, and the 4th LED is now on. So there you have a very simple application of the operational amplifier. Voltage monitor using LEDs as indicators. I hope you liked this video. Thanks for visiting my channel, and see you in the next one.